You finally saved enough to finish your custom build. You slot in the components, boot the system up, and then the screen goes black. But the real shock comes when you log online to replace the parts. If you look at the receipt for standard consumer memory, the numbers defy standard tech trends. DDR5 kits that cost around 8,000 rupees just months ago have doubled or even tripled in price across multiple regions. The pricing is so severe that it is actively freezing the market. Recent surveys show over 60% of PC enthusiasts are completely abandoning their plans to build new machines over the next 2 years. The strangest symptom of this drought is what is happening to the older generation of hardware. Manufacturers are slowing down production of DDR4 chips, meaning even outdated inventory is becoming scarce and rising in resale value. The general rule of consumer electronics is that aging hardware gets cheaper over time. Right now, that rule is broken. This squeeze extends beyond custom desktops. The everyday laptop market is actively downgrading its baseline models to cope with the severe lack of available memory chips. To keep retail prices accessible for the average buyer, manufacturers are increasingly soldering smaller capacity memory modules directly to the mainboard. The ability to upgrade your own machine is disappearing. Where official hardware becomes scarce, a secondary market moves in. Online marketplaces are currently flooded with relabeled, defective, and counterfeit RAM sticks targeting desperate buyers. The entire consumer hardware ecosystem is starving. To find out where the global supply went, we have to look up the supply chain. At the very highest enterprise level, the scale of computing shifts from personal machines to massive industrial server farms. We tend to think of artificial intelligence as weightless software, code living on a screen. But generating that code requires a vast, heavy, and intensely power-hungry physical footprint. Training modern AI models involves processing global datasets simultaneously, analyzing trillions of parameters across dense clusters of high-speed processors. Moving that much data requires a specialized technology called high-bandwidth memory, or HBM. It is the only type of memory capable of feeding data to these processors fast enough to prevent a bottleneck. Building an artificial intelligence is a brutal problem of physical logistics, heavily dependent on securing massive quantities of rare, specialized memory chips. The companies manufacturing these chips, like Samsung, SK Hynix, and Micron, operate within strict physical limits. Silicon fabrication is a zero-sum process. There is only a fixed amount of highly refined raw material and specialized cleanroom space available worldwide at any given moment. This chart visualizes total capacity as a fully occupied pipeline. Normally, production is balanced between consumer parts and enterprise hardware. But because AI pays premium rates, manufacturers are dismantling consumer lines, dedicating that finite space to AI servers instead. Manufacturers have cleared affordable consumer memory from their global production schedules to prioritize the massive hardware requirements of AI servers. Major manufacturers project that this structural bottleneck will choke the market until at least 2027. Price stabilization will only be possible closer to 2028, assuming new global production facilities can finally come online. While next-generation technologies like DDR6 are currently in development, they will launch directly into the shortage, arriving with extreme premium price tags out of reach for most everyday buyers. The most practical survival strategy right now is restraint. Unless your current machine is entirely failing or you require heavy workstation capabilities, the best financial move is to delay upgrades and maintain the hardware you already own. The individual consumer is no longer the priority. We have been displaced by the immense hardware demands of data centers and server clusters. The surge in artificial intelligence has restructured the physical tech economy. Manufacturing pipelines are now locked in on enterprise contracts, leaving everyday buyers to fight over the remaining scraps of silicon.